Greetings, ladies and gentlemen. My name is James Paris White, and today I will be doing my final examination presentation on the unit circle for my History of Mathematics class. Our agenda is quite basic today. We'll be going over an introduction, brief history, relevance of the unit circle, trigonometric identities, a few examples, and then we will conclude. I was first introduced to the unit circle in the 10th grade in my geometry class. I wasn't a very strong advocate for math. I actually disliked it very much. I was a lover of English at that time, and now I'm a math major. So we see how the story can get turned around. I was introduced to the unit circle after the subject with a lesson in geometry where we were talking about the hypotenuse and the legs of different triangles. Alright, so topics that include the unit circle will include geometry, calculus, trigonometry, and pretty much all of the math classes after geometry. The unit circle is a certain topic that will come up multiple times. It won't be directly about the unit circle, but it will be things that have branched off from it, and you will learn about that shortly. So what is a unit circle? Well, the unit circle is made up of a circle with the radius of 1, diameter of 2, the circumference of 2/7. It lies on the xy plane, and it can be expressed in many ways. The first way it can be expressed is in degrees, such as this. Starts at 0 and it does a full rotation to 360 degrees. You can express it in radians, which is pi. So you start at 0 and the full rotation will be 2 pi. Well, pi is equal to 180. So the degrees and the radians are actually equivalent. And the last way you can do it is by coordinates. 1, 0, 0, 1, where your x coordinate will be equivalent to the cosine number, and your y coordinate will be equivalent to the y. The expressions of cosine, sine, and tangent can also be expressed in graphical methods. As you can see, we have sine graph here, cosine graph here, and the graph of tangent here. Alright, now on to some history about the unit circle. Like most things or theorems or lessons in math, we can't credit just one person or one origin. We will have to say a lot of people in a lot of different nationalities and times, people of different history times contributed to the unit circle. So for the unit circle, going back to history, we have trace of the Babylonians, Egyptians, ancient Greeks, Indians, and the Islamics for helping with the creation of the unit circle. So how did each of these civilizations help contribute to the unit circle? Well, as for the Babylonians, they had many astronomers, and with that, they required the measurement of the angular distance. To the Egyptians, they used basic forms of trigonometry to build the Great Pyramids and the Sphinx. And we know that the Egyptians were very, very creative when it came to architecture. On to the ancient Greeks, they birthed the father of trigonometry, which is Hipparchus, and that is spelled Hipparchus. Going down to the ancient Indians, Siddhartha was the first to define sine and cosine, which is very important to the unit circle, if I may say. The Islamics, they were the first, and they were known for making tables for sine, cosine, and tangent, and I will show you all the tables later that they created. They also were the first to do the definition of tangent, which we know as tangent equals sine over cosine. They also came up with the equation sine capital A over sine little a equals sine capital B over sine little b, and sine capital C over little c, which basically helps us find the third angle if we're using the sine methods. Alright, so as every student would like to know when using the unit circle, how is this useful? I will tell you all about real world situations in the latter part of the presentation, but for now it will be about the math section. So how can this be useful? Well, it makes finding angles easy. However, you can't move too fast. You have to know the acronym all students take calculus. And it goes, so this is quadrant 1, all, where all the trig functions are positive. So cosine, sine, and tangent, they will all be positive in this quadrant. Quadrant 2, only sine is positive, sine and cosecant. Alright, quadrant 3 would be tangent and cotangent are the only angles that's positive. And lastly, in quadrant 4, cosine and secant will be positive. Alright, so we go to an example. Like I said, the unit circle makes life easy. Alright, so if someone wants to know what is the exact number for cosine of 30, well, we will go to our unit circle. We will find where 30 is on it, and as you can see, it's right here. Then we go to our coordinates, and we know that cosine is in the x value and sine is in the y value. So we know that cosine of 30 is the square root of 3 over 2, and the sine of 30 is 1/2. Alright, moving on to the other parts of the circle. In quadrant 2, we know that only sine is positive. So if we want to know cosine of 120, that would be -1/2, and sine of 120 will be the square root of 3 over 2 in the positive persuasion. Alright, moving on to quadrant 3, we want to know what cosine of 210 is, and it is negative square root of 3 over 2, and sine of 210 is -1/2 because it's in the third quadrant where only tangent is positive. And we know that tangent is sine over cosine, and we know that anything divided, two negatives divided by each other will give you a positive number. So this is a proof of that. Alright, and then we go to our last quadrant, which is the fourth quadrant, and we want to know what cosine of 300 is. And since we're in the fourth quadrant, we know that it's going to be +1/2, and we want to know what sine of 300 is, and we know it'll be negative, and it'll be negative square root of 3 over 2. And that is how the acronym all students take calculus is a very good helper for finding your angles if they're positive or negative, and this is also a good helper of seeing what your angles are using the unit circle. Alright, so let's bring back up the relevance of the unit circle. So like I once stated, the first time I was introduced to the unit circle was in the 10th grade in my geometry class. Alright, so the first thing I learned about the unit circle after the diagrams as well were the basic trigonometric functions and identities. Alright, so the second acronym I learned after all students take calculus was SOHCAHTOA. And it looks a little like this, and I know that looks foreign to the beginners, but an easy way to remember this, my teacher told me, was "Oh hell, another hour of algebra." And SOHCAHTOA, and it basically just lets you know, so it lets you know that sine is equal to the opposite side over the hypotenuse, cosine is equal to the adjacent side over the hypotenuse, and tangent is equal to the opposite side over the adjacent. And this is referring to triangles, and I will show you all that soon as well. Alright, so the opposite of sine would be cosecant, which is just 1 over sine. The opposite of cosine would be secant, which is 1 over cosine, and the opposite of tangent will be cotangent, which is 1 over tangent. Alright, so the next portion we learned in class were the special right triangles. Now we have two special right triangles, which are the 45-45-90 triangle and the 30-60-90 triangle. So we'll first take a look at the 45-45-90 triangle, which is the easiest to me. So on this diagram, we'll be focused on the 45 at the bottom corner. Alright, so the adjacent angle to that would be 1. The opposite angle to that would be 1 on the vertical leg, and the hypotenuse would be square root of 2. And we know that cosine is the opposite angle over the hypotenuse angle, which in this case is 1 over square root of 2. However, we can't have a radical on the denominator, so we just simply convert that to be square root of 2 over 2. Alright. Switching over to the other special right triangle, which is a 30-60-90 triangle. We're focused on the 60 located at the bottom. Alright, so the adjacent angle to that would be 1. The opposite angle would be square root of 3. And the hypotenuse would be 2. And as stated once before, we know that cosine is opposite over hypotenuse. So in this case, we know that cosine of 60 is the square root of 3 over 2. Alright, so I just showed you guys what I did in the 10th grade in high school. Now we can fast forward to my freshman year in college, where I took pre-calculus 1 and 2. The unit circle was pretty much a refresher. The students should have already been shown, or they should have some sort of background with the unit circle. Not saying that they were perfect. There was practice, but the main thing that I learned from pre-calculus in the unit circle section was how to convert degrees to radians and radians to degrees. Alright, so for starters, the first thing we learn is that 180 degrees equals pi. Let me fix that. It's always good to have your notation so you know what you're talking about. Alright, so 180 degrees equals pi. Alright, the first thing we're going to do is go from degrees to radians. Alright, so we're starting off with 270 degrees. The formula to convert from degrees to radians is you take the number you have and you multiply it by pi over 180. So in this instance, we say that 270 degrees is equivalent to saying 3 pi over 2. Alright. Now I'm going from radians to degrees. Say we have pi over 6. The formula to find your degrees from this would be the radians you're given times 180 over pi. So here we see that pi over 6 is the same as saying 30 degrees. Alright, so moving along from pre-calculus and trigonometry, the unit circle was something we would have to know like the back of our hand. So I would just say we had to be very comfortable with our trig functions. For example, things that we just have to know, like sine of 45 is equal to sine of pi over 2, which is the same thing as saying sine of square root of 2 over 2. They're all the same thing, so you have to know that. You have to know things such as sine squared of x plus cosine squared of x equals 1. It's just things you have to know. So in conclusion, the unit circle is very helpful. It still is very helpful. I'll be taking advanced calculus coming up this year, abstract algebra. I'm pretty sure that those functions and identities are things that I'll have to refresh myself with again. Just some real world situations that the unit circle might come in handy for. So we could say, for instance, there's a car accident. The officer or the insurance people will have to know who's at fault here. With the unit circle, we can measure by the angle of the hit who was wrong, who got a fishtail, who was speeding through a light or a stop sign. So the unit circle has been very helpful. I'm glad that I had the chance to share this with you all, and I'm glad that I refreshed myself with going back with this. I'm always happy about going deeper into things that I learned, so I'm glad to know where the unit circle originated from, as well as just going back. 10th grade for me was 5 years ago, and I can see how it's still relevant in my life. Thank you.